Okay, Trig Identities video for the 3U class. And this fits in with our D1 topic. So here's our trig identities. We got our quotient identity here. We got our Pythagorean identity here. And we got our reciprocal trig ratio identity here, reciprocal identities. So all of these identities will be given to you on the test, and your job is to just take the equation I give you and try to prove it. So you should also know that from these identities, sine squared plus cos squared equals 1, you can also rearrange that to help you, that sine squared theta equals 1 minus cos squared theta, and cos squared theta equals 1 minus sine squared theta. So those are other ones that you can come away with. And also knowing that cotangent is 1 over tan, you can also reason that cotangent theta would equal cos over sine. So those are some that you could come up with on your own. Okay, so say we have an identity to prove. Try to keep these so we can see them. Okay, so let's say we wanted to prove that tan squared theta plus 1 was equal to secant squared theta. So we want to prove this. Okay, so rules are you can deal with one side at a time. So there's the left side, there's the right side. So let's say we're just going to deal with the left side because it's the more complicated side. It's usually easier to start with the more complicated side. So the left side is equal to tan squared theta plus 1. So we're just trying to think of, okay, what can we sub in for tan? Well, up here I see that tan is equal to sine over cos. And if you want to square them all, you can do that. So we can say that tan squared theta is actually equal to sine squared theta over cos squared theta plus 1. And then anytime you see like a plus with two different things, it's nice if you could try to add them. So we want to make common denominators. So this is like 1 over 1. So if we want them to be common denominators, I think we'll just multiply this side by cos squared theta, multiply the top by cos squared theta, so that we'll now have sine squared theta over cos squared theta plus cos squared theta over cos squared theta. I'm just going to continue over here. And then if we add our fractions, we'd get sine squared theta plus cos squared theta over cos squared theta. And using our Pythagorean identity, we know sine squared theta plus cos squared theta is actually just equal to 1. And we're done, because 1 over cos squared theta is one of our reciprocal identities. So 1 over cos is secant, so 1 over cos squared must be equal to secant squared theta. So we proved that our left side is equal to our right side. Therefore, tan squared theta plus 1 is equal to secant squared theta. So let's just show one more example. Sorry, you won't be able to see the trig identities. Let's just try a tricky one. Okay, so let's try sine theta over 1 plus cos theta is equal to 1 minus cos theta over sine theta. So here's a tricky identity. So both sides look crazy. So pick one. Now I'm gonna start with my left side. Okay, so my left side is equal to sine theta 1 plus cos theta. So it's not really obvious what to do here. There's nothing you can switch sine or cos into that would make sense here. So this is where it gets a little tricky. If you're not totally sure what to do, for some reason, difference of squares shows up a lot in trig identities. So it's really handy if you remember difference of squares. So difference of squares is where you would have two terms like x squared minus 16. They're both perfect squares, and they're separated by a minus sign, so that when you factor them, they factor into two brackets, x minus 4 and x plus 4. And having two brackets like that, where the brackets are identical, but one's a minus and one's a plus, it makes so that when you expand it, when you do the FOIL or whatever you do to expand it, that middle term gets eliminated. So you just end up with x squared minus 16. So we're going to use our knowledge of that to turn this into a difference of squares. So see how we have 1 plus cos? We're going to treat that as having x plus 4. So we need an x minus 4. So we're going to multiply this by 1 minus cos theta. Just because we don't know what else to do, so it's something. And whatever we do to the bottom, we're going to have to do to the top. So we're going to have to multiply the top by that as well. Okay, so then the bottom, 1 plus cos, 1 minus cos. So if we're relating it to x minus 4, x plus 4, it should give us 1 squared, which is 1, and then it should give us minus cos squared theta. But if you're not sure, you can test it out by just expanding 1 plus cos, 1 minus cos, the old-fashioned way, multiplying everything in the first bracket by the second bracket, and you'll find that's what you do get. So that's what the, sorry, I jumped ahead to the denominator. That's what the denominator gives us, 1 minus cos squared theta. The numerator gives us, well, sine theta times 1 minus cos theta, which we're just going to leave like that for now. Now using my Pythagorean identity, I can actually switch my denominator into something. So remember your Pythagorean identity says sine squared theta plus cos squared theta equals 1? And remember I was telling you if you rearrange those, you could isolate sine or cos. So it turns out 1 minus cos squared theta is actually just equal to sine theta, sine squared theta. So if we were to cancel out a sine squared, one of the sines with one of these, we just end up with 1 minus cos theta over sine theta, which is our right side. So we just proved our left side is equal to our right side. And that's an example of how to do a couple of trig identities.